And this video is on the explanation of schema design and SQL queries of our project Blood Bank Management System. I, along with my classmates Mukul Bisht and Sonalika Arneja, created this project under the guidance of Dr. Shikha Gupta. This project aims to provide a simple solution of managing the blood bank system. So let's straight dive into the schema design of our project. Schema is basically a description of the database and it is specified during the database design. Schema gives a logical view of the database, and before getting into this schema design, I hope you guys have watched other two videos, that is the video of case study and ER of our project. If not, please feel free to check out the playlist, and I suggest you to watch those videos as those videos will be important for you to understand the schema design. So getting back to our schema design, these are all the tables in the schema design. This is the blood bank table. Primary key of this table is blood bank ID. Other attributes are as follows: blood bank name, address, state, PIN code, contact, manager name and manager mobile. Other table is donor, whose primary key is donor ID. Other attributes are as follows: D name, blood bank ID, gender, age, contact, blood group, state, PIN code, disease, registration team ID, date of registration, last date of donation, amount of blood donated. This is the blood table, whose primary key is blood ID. Other attributes are bank ID, bank name, donor ID, blood group, donor name, analyst ID, donatable, date donated. This is the patient table, whose primary key is patient ID. Other attributes are P name, blood ID, gender, age, contact, blood group, disease, registration team ID, date of registration. This is the donated blood table, whose primary key is blood ID. Other attributes are donor ID, donor name, patient ID, patient name, date of donation. And the other two tables are hospital and disease. Hospital's primary key is hospital ID. Other attributes are H name, that is the hospital name, address, state, PIN code, blood bank ID, blood bank name. In the disease table, we have a combination of donor ID and disease as the primary key, because one single donor can have multiple disease, so that hence the combination of these two creates the primary key of this table. And as you guys can see, the lines or arrows, whatever you call it, represents the relation between the table. Like, let's take an example of these two tables, blood bank and donor table. So the donor is related to the blood bank via this blood bank ID. So this blood bank ID will serve as the foreign key. And as you can see the other relations, it is self-explanatory. And as you guys can see the other explanations. So let's move on to the next slide. So this slide contains the screenshot of the table. So basically we designed the database using SQL, which is the most popular language, and we created this database on Oracle database server. So these screenshots give us the description of the tables which we created on the Oracle database system. So as you can see, this is the blood bank table, this is the patient table. Below that there are columns which are also called attributes, and so like the blood bank ID, its type is varchar and its length is 15, and similarly this is the patient table, and as you guys can see the attributes and columns. You guys can pause the video and check the type of the different types of attributes. And these screenshots are of the table hospital and donor. Donor table is quite big because it contains so many attributes and columns. These tables are of disease and blood donated, and the last table is of blood. So that was all for the SQL design part. Now let's move on to the SQL queries part. So the first query says find names of all blood banks where blood group O negative is not present. So in the select clause we have written blood bank name, blood bank ID from blood bank table, of course, where. So here what we have done is that we are selecting that blood bank's name which is not in this relation, and this relation gives away the blood bank's name which contain O negative blood group. Let's move on to the next query. Next query says that find names of all donors whose blood group is B positive located in the PIN code 110089 and the donated blood is found donatable but has not been donated to a patient. So in the select clause, donor's name, donor's ID from donor table where blood group is of B positive type and the PIN code is 110089 and the donor is not in this relation. This relation gives away the list of donors whose blood has been donated. As you can see, we have joined two tables, that is the donor table and donated blood table. So this relation will give the donor IDs of those donors whose blood has been donated, and to satisfy our query we have used this not in statement. You guys can pause the video and check the queries by yourself, and if you guys have any doubt you can write it in the comment box. Let's move on to the next query. The third query says list the name of the donors next to their address who belong to the AB positive blood group and are female and do not have any disease. In the select clause, donor ID, donor name, address from donor table where gender is equal to F as in female, and blood group is AB positive, and disease is null. So basically, if there is no disease associated with the donor, so in that attribute for that donor, the value that will be stored is null. So basically this statement says disease is null, as in the donor has no disease. Let's move on to the next query. This is the name of registered donors of age 18 to 28 years from pin code 110045 with diabetes as their disease. Select in the select clause donor ID, donor name, blood group from donor comma disease table, where age is greater than 18 and age is less than 28, and from this pin code, and the donor ID is in this relation. So this relation basically gives the list of donor ID that has disease name as diabetes, and that relation is formed on the join of donor and disease on donor ID. D dot donor ID is equal to S dot donor ID. Let's move on to the next query. The last query says list the registered donors who donated blood and who belong to the blood group considered as universal donor, as well as the patient who belong to the blood group considered as universal recipient. So in the select clause, donor ID, donor name, blood group from donor table, where blood group is O positive. O positive is considered as universal donor, and it will form a union from patient table, and from the patient table we are selecting patient ID, patient name, blood group, where blood group is AB positive. So that's all for this video, guys. If you guys have any doubt, feel free to write it in the comment box, and we'll be happy to resolve your doubt. Thank you so much.